Hey, what's up, dudes and dudettes? Brad the Guitarologist here. I got a bit of a cold today, so you have to forgive me if my voice is not great and cracks a lot. But this is what I believe to be early to mid 1970s Mesa Boogie Mark I. This is owned by Greg Martin of the Kentucky Headhunters. I looked at his Mark II not all that long ago. I'll put a link up here if you want to go check that one out. I'm not really fond of working on Mesa Boogies, as you guys probably know by now if you've watched the channel for any length of time, but these are kind of an exception. These Mark Is are not too bad to work on. We're going to get in this thing, see what all's wrong with it. I can tell already that it's got some missing buttons there on the EQ. Other than that, it looks like it's in pretty decent shape. Grill cloth is in okay shape. There's a couple of cup marks there. I didn't do that, I promise you. I wouldn't do that to an amplifier ever, except maybe a Mesa Boogie, but not this one. But here's the back. You can see here, it's, I mean, this is, you know, I guess you could say is at least looks pretty early. There's a 12 and an 82 stamped right here. I don't know if that means anything. I'm not sure what's up with the Groove Tubes logo there, but these are not Groove Tubes that are in it. Sorry, I'm getting a phone call. As usual, when I try to do something, I get a phone call. Okay, so this is equipped with one of these Mesa Black Shadow speakers. These are whopper of a speaker. MS-12 is the model on that. There's a serial number if anybody's counting on that. 8 ohms, 150 watts, and I can believe it. Look at the size of that magnet. This thing is enormous. 2 cell 6s for the output. And can you see the problem? I mean, with this, just generally speaking, for you know, as opposed to some of the most of, or if not all, of the Fenders and Marshalls and stuff that we normally see. You know, usually the tubes are really accessible. They're lined up along the back edge. But on this, it has so many tubes, and the layout of the boards is such that you can't do that in these. And so they have these 2 big power tubes, and then you've got all your preamp tubes up in here where they're almost inaccessible. Not a great layout for an amplifier, if you ask me. It's not very user friendly. We have a effects loop. Here's our reverb presence. This thing actually has a Fender plug on it for the speaker, and that might even be original. I think Mesa was using all kinds of different parts for these. Here's our fuse. I'm not sure what our fuse is supposed to be. Oh, 2.5 amp. Let's go ahead and check it before we do anything else. I can't remember for sure what he said the problem was with it. I think maybe he just wanted it gone over as a matter of course. I don't think it was malfunctioning. I think he just wants it serviced. This is a 3 amp fuse, so we're going to replace this with the proper fuse. Okay, so actually before pulling the chassis, I'm going to go ahead and see what all's wrong with it, just to get an indication of what we're looking at. So we'll go ahead and turn it on, and we'll dial it up slowly on the variac over here. Make sure we don't have any shorts or anything like that major going on, which it doesn't appear that we do. The indicator light will not come on. I think it is neon, so it won't come on until it gets enough voltage. At least I think that's what these are in this. All right, yeah, there it goes. About the time the light comes on, we're also getting some sound at 89 volts on the input. Looking good on the current draw. Okay, so there's about 120 volts, 0.69 amps. I don't know if you can hear this, but I've got some. Hear those noises. I'm putting the EQ in and out. Now it's out. lot of reverb. Well, I guess let's plug into it for a second and just see what it... We'll see what it's doing with a guitar in it. You have to take this sound clip with a grain of salt because I will really be overloading this this microphone. It's set up for my voice on the desk, not for capturing amps. I suppose if I was a professional, I would adjust that before doing anything, but hell with it. Okay, so how's this set up? This is set up so that volume 2 works how is this set up? The gain boost it's getting less gain. Yeah, I can't remember how these things go. They're so weird. Let's see if we can get a rock and roll tone at really low volume here. Really low volume. Well, the EQ seems to drop a lot of signal out, which I don't think should be happening at linear, or at, I mean, not at linear, at what am I trying to say here? When it's equal across, it should, I don't think it should drop signal like that. And the boost, when you pull out the boost, I'm not sure why that's disappearing either. See, look, gain goes away when you pull that out. That's a gain boost. It should be giving me more gain, right? It gives me less. Tons of reverb there, which we don't really need, but you know, so I wonder what might be going on with that. Not really sure. So we do have a couple of issues. I may go ahead and give him a call and figure out what the problem was with it, as I really don't remember. You know, I kind of picked it up from him and he gave me a brief synopsis, I think, and it's, you know, sometimes that just flies in one ear and out the other, because amps tend to run together after a while and you don't remember what one person said his amp was doing versus, you know, another guy who said he had a different problem. So yeah, that reverb is not doing the tone any favors either. But one thing I can tell already is that, you know, there's no problem with the power supply or anything like that, because we're looking really good on all that. Our voltage at 120 volts, our current's not excessive, at least not, you know, with playing this low. Power draw is not excessive. That looks about right, actually, for what this amp should be drawing at idle and low volume. So yeah, that all looks pretty good. I don't think there's a power supply issue at all. I mean, we could go ahead and change the capacitors since we're going to be in here anyway, which might be a good idea just for long term, you know, stability of the amp and everything like that. But you know, I don't see any other issues offhand. So other than it gets quieter when I engage the parametric EQ, and also it gets quieter when I engage the gain boost, which I would have thought would have given it more gain. So yeah, that's odd. Oh, one thing I did not check. I did not check the second channel on its own. That should just go through. I think it bypasses this control and just goes to this one. So it's more of a clean channel. Okay, see, now that's doing what it should be doing with the EQ. See, when it's out, the EQ, the volume doesn't drop as much as it was doing on the other channel. Maybe a little bit, but maybe that was just a function of how low I had the master volume too, so it could be all that is. Having the reverb control on the back is not really that convenient, because you know, sitting down like this, I can't reach up and just adjust the reverb so it's not overdriving. I think the reverb being up as high as it is right now is contributing to some fuzz in the tone that I would prefer not be there when I'm just playing cleans. All the controls definitely need to be cleaned. There's some garbage in that low note. I think it's down to that dirty pot right there, that dirty master volume pot. I think it's contributing to it. Because what's happening on the low notes is it's vibrating everything in here, so it's kind of, you know, microscopically moving that control internally, and it's, you know, hitting that dirt. Yeah, definitely a lot of dirty controls. Other than that, I think it's going to be pretty standard to do a service on this. Okay, here we are with the chassis out on the desk, and what I'm seeing here leads me to believe this might be a 1977 amp, because we have a 6 and a 77 here, and that would kind of make sense given what, you know, I'm seeing just generally. We have a 606 EIA code here for Schumacher 703. I believe, again, it's 1977. Schumacher transformer here. 77 on that choke. I believe that's a choke. Or maybe that's the reverb driver. Is that the reverb driver? Oh. No, that's the choke. This is the reverb driver right here. It's a 606 621, so that's probably 76 on that one. And this one is and they're all labeled Mesa. This one's labeled Mesa 2. It's kind of hard to see from this angle, but that's going to be the original output transformer too. Ooh, got a pin sticking out right there on that socket. You can see that it's kind of just popping up there. No huge deal, but we'll keep that in mind. We're going to go ahead and spray and clean all these sockets and everything. I want to pull the tubes and just see what kind of tubes we have going on here. This should be the phase inverter over here, I would imagine. I believe it is. This has got an 87 code on it, 1987. So I think this thing may have been serviced in 87. And this is a Hungarian tube. Westinghouse, made in Hungary. Oh, you don't see too many of those these days. It's probably still a good tube, I would imagine. I would say all the tubes are probably fine in this amp. Just given, you know, what it was doing when I fired it up, it seemed to be acting okay. It may have had a slight bit of microphonics, so I'll run through and see if there's any way to swap around tubes to get the best results for microphonics. But I don't think I'm going to have to do much beyond that, but other than spray sockets. I mean, that wouldn't surprise me if this was an early Chinese tube, like maybe from the 80s or 90s, probably. That yellow script on there. Okay, this is a GE tube. It's labeled groove tubes. So 12AX7 groove tubes labeled, but it's GE. You can tell by this the script and the way that you see these little dots down here below the script. See, 12AX7A USA, and it has several little dots down here below the printed. That's a GE tube all the way. So that probably is that's a good candidate right there, possibly to put in V1 if we find any microphonics in V1. All right, we've got a Chinese tube here in the V2 position. And this should be V1 here. And it's just a run-of-the-mill Sovtech in V1. Nothing to write home about, but should do the job. But you know what? I am going to go ahead and put this tube in V1, just just because I have a sneaking suspicion that this is, I mean, this is definitely the best tube in terms of the make. It's a GE tube. I want to put it in V1 just because, I mean, my suspicion is it's probably going to be the sweetest sounding tube in here, just based on past experience. But that's not 100% ironclad either. I just like to put the nicest tube in terms of what it is in the V1 position when I see it. And having already, you know, turned the amp on and determined there aren't any faults or anything to track down, where swapping those tubes might confuse me or confuse the diagnosis. I'm not worried about it too much. I'll go ahead and pop that over there. So let's go ahead and flip it, and we'll see what else needs to be done here. Okay, well, we've got our usual Mesa mess in here, really. I mean, but not as bad as some of their later amps. We've got the big capacitor. This should be 100 microfarad over here, and it is that silicone, or I guess that's silicone. I'm gonna have a hard time probably clipping that thing out of there. That's in there with some adhesive. It looks like silicone, but I think it's not silicone. It's something tougher than silicone. They've got that thing really glued in there. It's from 1977. This one is also from 1977. That's 77. Yeah, 77 on that one too. Yeah, these are all original caps from 77. So it looks like it was retubed somewhere along about 10 years or so after it was new, you know, around 88, 87, 88. It was retubed, and these caps are still the original caps. So we're going to come in here and replace these, all these caps. Now that big ass cap down there, I'm going to have to probably cut it out. I don't see anything burned or cooked or anything like that, but we will come in here and spot check most of these, the critical resistors, and we will replace anything we find bad that's power section related. We will definitely replace with metal film. We've got some socketed transistors over here. Let's see, these two wires, this black and white one. Okay, so those are bringing the power over. It's probably not anything I'm going to have to mess with, other than maybe just cleaning those sockets for the transistors or making sure they're seated. These typically are not great transistors. They tend to fail in older equipment a little bit more often than some of the other ones you see. These silicone ones hold up pretty good, and these are kind of spotty, hit and miss. But I don't think there's anything wrong with this board. But we are going to replace this electrolytic over here as well. Some of these other smaller electrolytics over here down on the board, like this one and this one and this one here, we may replace those, but I don't think so, because it's going to be quite a chore to get down to them, because it's really crowded down in here. The ones that are easiest to reach, I may, but they're not likely to have failed in any way. I don't think they're a problem, so I don't know. Those might end up staying, but the big power resistors, or excuse me, capacitors for sure will need to go. So if we look at these inductors, see this row of inductors right here? For those of you who saw my video on the de-armand wah pedal, you'll recognize that inductor and the brand. What is that, Esco or Seco or whatever? I don't know. I'm not sure what brand that is. I'll have to research that, because that's the exact same brand that was in that wah pedal. I do know that when you have one of these that's bad, if you call Mesa, they will send you one. Whatever one you're looking for. You could probably also find them elsewhere too, but it's best just to call Mesa, because I think they have these boards, and they also have all the parts for the boards still. So, like I said, I've never had a complaint about Mesa at all in terms of them helping you try to solve issues with your amps. The main problem is just the way that they're laid out and stuff. They're just not ideal, especially if you're used to working on, you know, Marshalls and Fenders and stuff like that. I mean, I'd even rather work on like an old Valco or something with all the turret strips than something like, or the terminal strips, than something like this. Anyway, enough of my yapping. Let's go ahead and just do the recap. We'll come back and clean all these controls. Well, I might as well go ahead and clean controls now. That one's going to be next to impossible to get to right now, so. The master volume, this is the one that was giving me the most grief. Okay, these faders can be tricky. I've got to make sure the liquid gets down in them. Damn, these things are... I think somebody glued these on, and when they glued them on, they glued them really close to the chassis, so it's kind of rubbing, when you use it, it's rubbing off all the paint. Okay, so there are all the controls. We'll go ahead and do the jacks as well. Okay, one thing to pay special attention to is this jack right here. This is on the loop, and if this is not bridge tight right here, you'll lose signal right there. Okay, so there are all the jacks cleaned. Now let's go ahead and change out all of the capacitors, and then I think we'll just give this thing a test from there, because I don't think it's going to need anything else, unless there's a microphonic tube somewhere. Okay, well, after some tugging and pulling, I finally got that capacitor out of there, and it was, man, that sucker was in there. I had to actually take a hammer and a screwdriver and hammer along the edge and pry the thing out. It was really adhered in there. Oh, you like my hammer, by the way? I made this out of a dowel rod, and these are the legs of my new kitchen stools. I had to cut them down so that they would go below my bar. So I made a bunch of these. I even got little handles on them and stuff. Really cool. I gave one to my wife and one to my niece, and I've got a couple other ones I might give away to somebody if somebody wants one. But so I ended up with a bunch of these, and it was really nice oak and just solid pieces of oak. And I'm like, what the hell am I going to do with this? I don't want to throw these away, because I had I had 4 stools, so 12. I had like 12 of these pieces like this. I had to cut down off of the legs, so I've got enough for 12 of these little hammers. Man, I was actually shocked as well. I don't know how many of you guys are into woodworking or crafts or stuff like that, but man, the dowel. This is a 7/8 inch. I believe it's 7/8 inch. Yes. Oak dowel. I wanted to use oak because this is also oak, and I just wanted it to be consistent. But man, I was looking up just dowels, man, and they are so damn expensive. It is unbelievable. I think it was like $20 or $24 just for 2 dowels that are like 38 inches long, and I was just shocked that it would cost that much for 2 dowels, and that was the cheapest price I could find. That was like the bargain basement Amazon price. If you went to like Hobby Lobby or something, or one of the corporate stores, it was more than that. So crazy. But anyway, this amp is unusual. When they revised up for the Mark II, they did not include this cap that's down there. Kind of strange the way that they've got this. So this is a 60 microfarad, and it's 500 volts. Well, we've got these two that are 60 microfarad each at 350 volts. So basically you get something that is cut in half in terms of microfarads. So it's like it'll be 30 microfarad in total, but it will be 700 volts. Just strange the way that they've got that. We can see right here, okay, this is the Mark II schematic. So you can see right after the rectification, right here at this point, and before the standby switch, we have two 220 microfarad at 285 volt capacitors in series. They have 150K 1 watt resistors strapped around them for bleeders. So when the standby switch is closed, it feeds this node right here, which is the center tap of the output transformer. It goes through the choke and then on downstream. And we have 30, 30, 30 at each node downstream. But if we look at the Mark I, so right here we have two, and it's really hard to read, but these are 60 microfarad at 350 volt in series. We have 1, 2 of those. When the standby switch is closed, it feeds on downstream. Here's our center tap. This goes to the center tap of the output transformer. But you can see right here, we have another 60 microfarad at 500 volt capacitor to ground right here. So essentially what we have is this is going to equal 30 in total with a 60 over here at 500 volts. I don't know why they chose to do that. That's an odd configuration. I think they had a better idea and the right idea really when they went to the Mark II, which just has these two 220 microfarad capacitors in series, and that's going to drop down to about 110 or so microfarads in total. So that makes a hell of a lot more sense. I am going to go ahead and do that, and I already have the capacitors anyway on hand. I have just for Mesas. I ordered these just for Mesas a while back. So I have these on hand, 220 microfarad at 300 volt. They're F&Ts. I see no reason not to go ahead and use those and convert this to the Mark II setup on the power section. So we'll go ahead and do that. Okay, so I got these capacitors soldered in, but one word of advice: if you do not want to have to pull this red board right here out of one of these and in order to put these capacitors in, you will definitely want to just make sure that you clip the old leads off of the old capacitors. Make sure you clip the leads off. Don't try to desolder the capacitors, because on this side, on the positive side, the wires underneath, I don't know if you can see that one down there, I had to resolder that because it came loose. Those are connected to the old lead for the capacitor. So if you desolder that capacitor and don't just leave the old lead and maybe bend it over or something like that, that's what I recommend doing, because otherwise you'll have to pull the board, or you'll have to do like I did and sit here and try to get your tool down there to hold that while you resolder it back in. It's kind of hard to do from under there. So just a word of advice on that. Also, we're going to go ahead and, before we turn anything on or do anything like that, we're going to check for continuity on all of this stuff to make sure nothing did come loose and we don't have to pull this board and we have any shorts or problems. I don't anticipate we will, but it's just a added measure of safety and reassurance on my part. I want to make sure, for instance, all these grounds are connected across. I want to make sure that these two capacitors are connected in the center from here to here. All of that kind of stuff. So we'll check all of that and then before we fire anything up. Also, I want to, I'm not done yet. I have a couple more capacitors a little further down over here I want to do, but that's pretty much all of that. I'm going to add some silicone across here to hold these to keep them from rattling when this thing's really loud. I don't think it'll be an issue, but also just to add a little additional padding. These are really big capacitors, and they're going to be right at the very top of the cabinet when this thing goes back in the cabinet. So I just want to put a little bit something there to act as a bumper. They had they had these strips of foam in there before over here, but the adhesive is old, so I just want to add something there to just kind of hold those from rattling. It is now the next day, and we're back with this Mesa Boogie. It's out on the bench here. We're going to, oh man, that's still got 21 volts on that from where I was screwing with it earlier. Wow. Okay, well the voltage obviously doesn't drain very well from this amplifier when shut off, so I've got to definitely take note of that. Okay, so we have a signal coming in the input. We're hooked up to the oscilloscope on the output. Yeah, let's go ahead and fire it up. I'm just going to dial it up slowly on the variac here. I've already done this once off camera and everything came up just fine. As you can see here, I did silicone these loose capacitors together. It helps everything stick together. It minimizes any rattle when you hit certain notes. Sometimes you can hit a note on an amp, and because of the frequency, the resonant frequency of certain components, they will rattle together. And siliconing parts like that together prevents them from rattling and making undue noise, and it also prevents them from just shifting around. And we're starting to get some output here, as you can see, starting to come up. It's a bit of a squared off wave because I've got it kind of loud at the moment, but I can tame that all down. Let's go ahead and do that. As a matter of fact, we can lower the gain on that first stage if we want, but this is actually backwards. So pulling this out is low gain and pushing it in is a higher gain. It's backwards from what you might expect. And I think it's just on this example. It's not, I think it may have been wired backwards from the factory or something. I don't know for sure, but anyway, that's the way it is. All the controls are working. Everything seems to be working smoothly. I don't see any undue noise or anything taking place. So I think all of that is all right. Turn this little meter on here, and we'll go ahead and dial it up the rest of the way here. All right, there's 120 volts on the input. Turn the master down a little bit. Okay, so let's just take measurements at idle. So we've got 22.6 milliamps of current on the plate. That's plate current. So 0.0231 is what we've got on there right now, times the voltage, which is 465 volts. It's a little shy of 11 watts of plate dissipation at idle per tube on the output. That's low for a 6L6, but the thing is, I think this is probably about where I'll want to leave it. I may change it slightly, but I don't want to go a whole lot above that, to be honest with you, because I've kind of learned my lesson in the past on putting things to the 70% mark. 70% for a 6L6 is really about twice that dissipation at idle, but I definitely don't want to go that high. I may change it slightly. Now on Mesas, they don't have a way to adjust the bias like they do on Fenders. They kind of did away with that. It looks like this one has already been adjusted by someone in the past. You can see those few components over here, which are kind of tacked in there. You got a couple of resistors in series right there. Those are in the bias circuit. It's kind of hard to tell, but is that 2.2 and an orange, so 3, that 22K, and it'll be plus whatever this is. Is that brown? So 1.5 and 2, is that 1500? Is that 1500 plus? Well, that seems pretty silly. That can't be right. That's got to be 1500 plus, and that's a brown, so that'd be 1500 plus 220 ohms. Well, let's look at a schematic and see what that is. Here's the tap for the bias on this amp. We have a 470 ohm resistor before the diode, which is not what's going on in this amp. It has the diode first and then the 470 resistor. So I don't know if that really matters. Probably not. Here is the bias capacitor, smoothing capacitor for the bias voltage. And in parallel with that, there is a factory select. It says right here, factory select. It looks like it's supposed to be a resistor, but it says factory select. It doesn't give me a value. Here is the 1500 ohm resistor that's supposed to be here, but like I said, another resistor was added in series with the one that's here. I don't know if that was done at the factory or if it was done by someone, you know, subsequent to that at some point along the road. But this value has been raised to approximately 1800 ohms instead of 1500. This resistor right here, which does not seem to be present in the amp. What does this say? F white EQ power. That's bordering on something offensive. So the F is coming over to here. So that really only affects the EQ. So I'm not worried about that. That's not bias related. What is bias related though is this factory select resistor right here, and it appears as if none exists in the amp. If you were to try to rebias the amp using that resistor, that's also going to affect the negative voltage supply for the EQ section, and I don't know if that's going to have that probably would have an effect on the functioning of the EQ. So I think I'm going to leave it where it is. You know, I could come in here and try to fiddle with this factory select or put something here. You know, there's nothing in the amp. It was working fine before. It's working fine now. The thing is, you know, it's on the low side, so it's conservative in terms of plate dissipation. And if we look here, let me show you what's going on if we get this thing heated up. So if we bring this up to a point where, tell you what, let's get it to a point where it's just starting to kind of square off. If we turn this up to where the notch kind of starts to appear right here in the center of the waveform, back it off to about right there where we just got a nice square wave, and we'll check our readings here. 0.0713 times 418 volts. That is 29.8 watts of plate dissipation per tube right there. That is the maximum plate dissipation for a 6L6. You could run that like that right there all day and all night, jamming this thing, basically rocking the hell out of it. That would probably shake the walls right there, and you wouldn't hurt these tubes. So yeah, as far as I'm concerned, that's pretty good. I'm not gonna fiddle with that with this Mark I particularly, and I think also maybe with the Mark II. I'll have to take a look. Let me actually look at the Mark II schematic. No, it comes off the same tap, but it has its own diode rectifier and its own dropping resistor for the EQ section. So they do it a little bit differently in the Mark II. I mean, obviously this is better than the Mark I, and I probably could come in here and rewire this section to Mark II specs, and it would be an improvement. But like I said, I'm not going to mess with it. Everybody had a good year. Oh yeah. Alright, let's rock it up a little bit. We'll crank the gains. So hard to get a good sound with one of these. You got to really just sit here and dial it in. And this thing is so loud. The master at 1 is unbearable. EQ section is not very selective on this. I don't know if it's because it's malfunctioning or what, but it doesn't seem to be. Well, I mean, it'll get that chuggy thing. It'll do that 80s stuff, but you really have to work to get a sound out of it. That's a little bit more AC/DC-ish. I mean, honestly, as a gigging amp, I would not want this thing, just simply because it's so hard to get a sound that you want. That, you know, the minute you're able to dial in something resembling a crunch tone that's acceptable, then it's hard to get back to something else that's, you know, a clean tone that's acceptable. It's either or, you know. So for recording, it would be fine. But I just don't, as a live amp, I don't think I would want one of these for that. Unless I was using pedals, maybe. Might be alright for a pedal platform. kind of get it to crunch up, but the bass has to be all the way down and the treble cranked, and you got to pull the bright. The gain's got to be pretty high, but not all the way, or it'll start to kind of flub out. See there? It starts to flub if you get above a certain gain on the first stage there. Helps if you're in tune. Okay, so anyway, that's a 1977 Mesa Boogie Mark I. I hope you've enjoyed this video. If you have, hit subscribe down below. For now, we will see y'all later.